Hello everyone, my name is Mohammad Niazi. I'm a smart power engineer. I'm here to talk about electrical installation and design. I'm going to explain how we can design the schematic for a typical residential building. Please keep in mind this is only an introduction, so you have to practice and review much more to be expert. Okay, let's go. You have to get to know about the concept of the electrical system in any buildings. You can see the uh, important aspects in any plans for drawing. For example, lighting, sockets, fire alarm, lighting system. All of these are very important. Drawing with drawing software like AutoCAD or ePlan. Every schematic and diagram has contents to show all of the parts of the electrical design. So we have to specify the symbol and all of the role and condition as a guideline for operation engineer or technician as a clear. It should be noticed we have to calculate and drawing for lighting and cable or wire sizing and select suitable protection devices based on the standard. In this slide, you can see the main parts of the drawing. First of all, we have to explain the symbol and installation guideline for technician, as I mentioned before, and then start to draw a lighting system, socket, fire alarm, antenna, and telecom distribution diagram of the antenna and central antenna and telecom distribution diagram for power and main power panel and all of detail for earthing system and surge arrestor. About symbol and installation guideline, you have to know safety rule and condition because as you know the safety is first in any project, any practical project, and other rules like a distance between main power panel and switchboard of every floors or legal wires and protection device that you selected based on the standard and the below of this slide you can see some of the symbol like single phases, MCB single phases or three phases, earthing or meter and other symbols that we need to show in our diagram. I selected a building with 4 floors and ground floors for parking. For design, first of all, we need to architecture plan of the building. Uh, to drawing our plan or schematic. In right hand you can see the lighting system in different zone, for example in living room, kitchen, rest and bathroom, and you have to assign 4 or 5 line for lighting system. It should be good for follow the safety and every zone needs a separate line and you have to draw the switch to turn on and turn off the lights and choose the suitable lights in any area. As well as here you can see in the socket diagram uh, like a lighting system, you have to assign some lines for socket and supply all of the loads in the home. And pay attention, you need to draw the separate line for kitchen sockets and one independent line for washing machine. It's very, very important. And other diagram is about fire alarms and detection. You have to install some detector like a thermal and gas detector in kitchen and a smoke detector in the living room and other place, and make a secret and connection between all of us. And here is a alarm of the detector system. As well as for socket of telecom and antenna, we have to draw separate line to be clear for technician and implement this system in the building. Here you can see the telecom distribution, SLD and antenna. We have 4 floors, so we have to install for joint box for telephone and antenna. It's independent, and as well as we have to draw the power distribution diagram and specify the size of the cable and switchboard in any floor. This size of the cable and wire that I mentioned before, we have to use the standards. Uh, and here is a independent phase for supply the elevator. It is very important. And here show the lighting in the whole of the elevator. And we have to draw the power panel of the elevator and show the elevator system, engine room, and all of part of the elevator, and everything and every equipment needs to connect it to the earthing system for safety and protection. As well as this is a schematic of the main LV panel. You can see the independent uh, phase for elevator and 4 phase for 4 floors and 1 phase for the ground floor. And as I mentioned before, this size of the cable and imp of the protection device depend on the our condition rule and some policy of the community. And here is a switchboard of the any floor, uh, 5 line for lighting, 4 line for the socket, and 1 independent line for the washing machine. And here is a line for cooling system. Uh, Here you can see the very important issue of the any building equipotential and bonding. It is very important for protection and safety. Uh, you can see all of the pillars of the building. This building has 12 pillars, so we need to connect between all of these and use 2 branch, and these branches straight go to the earth box in here. uh, and you can see the foundations, pillar bondings, ground floor, first and other floors. So this is a connection between the earthing system, as well as you have to connect the gas pipe to the earth bus to make safety and protection from, against the overcurrent or over voltage. This slide shows the detail of the hole in the earthing system, depths of the hole, and how we can connect to the earthing system and earthbox. Very popular connection is Cadwell, and we have to install a copper plate with this size in the bottom of the hole, and then connect it to the box of the earthing system with the earthing wire with the specific size. And finally, you have to draw the surge arrestor system. It's very important for over voltage and over current and safety and protection against thunders. So you have to pay attention. We need two separate hole, one hole for breathing system and another one for surge arrestor. It's very important to follow it. Here is you can find a good reference for installation, electrical installation guide to table sizing, uh, select the suitable protection device, and other rule for PV panel, main panel, earthing system, bonding, and other concept of the electrical system installation.